Hey guys, so you guys asked me to do a dedicated graphing calculator video, so that's what I'm doing here today. So I have the chapter 3 review. I have my home graphing calculator, so it's not the nice color screen one. I have the practice FRQ that we did in class, and I have warm-ups that you guys are going to be seeing after, or you should have these warm-ups before you get to see this video. So yeah, anyways, so here we go. I'm going to start with the ones where we really need to use the graphing calculator part of the graphing calculator. So in your chapter 3 review, the first problem that you really start needing your graphing calculator on is number 3, and I highlighted it because you have this function f of x equals e to the x plus 2, and you're supposed to find at what value of x is the slope, aka the derivative, of the tangent line equal to 3. And this one isn't bad because we can do it by hand. All this work that I have done in purple is by hand, and I was able to take the derivative of f of x and by hand, and then plug in, or not plug in, set the derivative equal to 3, and then solve for x using properties of logs from last year in Math 3, and then I'm able to get my answer. In the chapter 3 review video, you already saw me work through that, okay? But I'm going to focus specifically on the calculator. So on the calculator, let's pretend you get stuck. You don't know how to do the natural log or the log properties, even though you should. They're from last year. But anyways, different story. You're just relying solely on your calculator. Here's what you got to do. You have to go to your y equals button, and you need to type in the function. So that is e, so second e, to the 4x power, arrow down, plus 2. And there's our function, okay? So if I were to graph it, here it goes, all right? It's a log, so it's going to look like a log on a graph, okay? Well, I'm trying to find the derivative. So in y2's spot, we're going to type in the derivative. So I need to hit math 8 d dx, and I'm going to hit alpha trace so that I could just populate in y1 so that I don't have to retype it, although you could retype e to the 4x plus 2, and that would work also. All right, but here's the thing. It says what value of x is the slope. So when is the slope, the derivative, equal to 3? So we have to think of setting the derivative f prime of x equal to 3. To put that in the calculator, you have to move the 3 over, so you have to subtract 3 from both sides, so that way you get the derivative minus 3 equals 0. Well, this is the equation that you have to type in. So here's the derivative, and now I want to minus 3 from it. And then what that's going to do, because I have it set, the equation set equal to 0 technically, whenever this graph crosses the x-axis, aka a 0 is made, that is going to be the solution. Okay, so we're looking for where it crosses the x-axis at. All right, so also I don't want both of these to graph at the same time on the graph. I don't need them both at the same time. So I just want to unhighlight the equal sign, and see now it's not highlighted anymore under the y1 equation. So it's only going to graph the y2, and that's what I want. So I'm going to hit graph. And then you gotta wait for it. Just waiting for this to stop moving over here on the right of my screen because I've got the older style calculator. Okay, it stopped moving. All right, so now I'm gonna hit trace, and I see a little blinking cursor. I want to try to get this as close to a y value of 0 as possible, and I can't. I have a negative 1.29 and then a positive 1. So the 0 is in between those two y values. I want the biggest negative I can go, or I guess the smallest negative I could go. So I need that because I need to find the 0, and we can calculate that in this graphing calculator. You have to hit second, calculate, and we want the 0. We want a 0. So you're going to hit 2 this time. And it says left bound. So on the left, I need a negative y value. Well, this is the very last negative y value I'm going to get on the left of the 0. So, because that's where I left my cursor, I'm going to hit enter. But then I'm going to need to hit my arrow to the right one. And so now I'm at the very next y value on my graph, and it's a positive y value. positive 1. So this is after the 0 there. So I'm going to hit enter. And so the left and right bound have been set. Now I'm going to hit enter again to guess. And so it tells me that the 0 is at an x value of negative 0.0719. So negative 0.072. Okay. So, and that's what we got by hand. Negative 0.0719 or negative 0.072, which is the answer. It was B. Okay. So that's how you do that one. So again, when you're calculating a 0, you need your cursor on the graph. You want to find where your 0 is. We know it's somewhere around here. That's where it's crossing the x-axis at. We know it's a really small number, and it's right before it passes the origin there. And so you need to get the negative number, the last negative number before it turns positive, pretty much. Once you get that, then hit second calculate, hit the 2 for the 0. You're already on the left bound, the last negative number before your 0, and hit enter. And then you're going to scroll to the right. So now you're going to set your right bound. You're at the very next number, which is a positive number to the right of your 0. And then hit enter again. And then there is the 0. Okay. All right. Now, luckily, a lot of these problems you can do by hand. So make sure you are prepared for both in case you get stuck on one or the other. Okay. It is a graphing calculator portion, so you're going to want to try to use your graphing calculator. It's going to save you some time. Okay. All right. Number 4 didn't require a graphing calculator. I mean, you could have used one, but you have the picture of the graph right there. You don't have to use it. Okay, so the next part where you're going to use your graphing calculator is the FRQ, the first FRQ, the graphing calculator FRQ from the review. Okay. You already saw the video, hopefully, of me going over it, so I'm not going to go over it again. I'm just going to go over the calculator part. So in letter A, says if the valve is opened after a large storm at 9:30 a.m. and remains open, at what time will the tank be completely emptied? So when a tank is completely emptied, that means we're taking the original function and we're setting it equal to 0, because 0 means it's on empty. It's 0. It's out of juice or whatever is in this tank. Okay. So rainwater, I guess. So what we need is we need to see the graph crossing the x-axis. That is going to tell us how long it's going to take it to empty out all the way. So we need to go hit our y equals button. So I'm just clearing out what I have in there already. And I need to type in the original function. So 4 times 1 minus, I need parentheses around that, x over 13. Close the parentheses, close parentheses again, squared, and there it is. Okay, and then I'm going to hit graph. And I see it coming down, but I feel like I need to see more on that side of the graph, so I need to change my window. So I'm going to change it to an x max of, let's go 20. Let's see what happens there. Oh, and then we see, like, it's like a parabola. It's going down and then back up again. So it's going to hit the x-axis somewhere around here. So I'm going to hit trace, and I want to scroll to that point. I want to try to get the smallest y value that I can get. Small, really, really small. And then now it starts getting bigger again. When you have that e to the negative 5th power, that means it's scientific notation. A negative exponent means that you move the decimal that many times to the left. So this is the smallest number it's going to be. So 12.978. And honestly, it depends on how zoomed in you are in your graph, what you're going to get. So the best thing to do is to round this to the nearest whole number, because when you're trying to answer the question, you don't want to be typing in decimals. You want to be as simplistic as possible. This is close to 13. So I would round it up to 13. I think when I did this video, I got 12.6136. And I must have entered it in, or I must have had it zoomed in differently, but I still end up rounding it to 13, because when I do it by hand, 13 is what I get. But honestly, 12.6 rounds up to 13 when you round it, because 5 or higher, bump it up, 4 or below, drop them off. So it would happen either way. Okay. So always round so that you don't have to deal with the decimal. You can deal with the decimal, but it might hang you up a little bit. So I just, round it to a number that's easier to deal with, a whole number. Whole numbers are easy to deal with, okay? So that's part A. You're looking for where it crosses the x-axis. You're trying to get as close as possible. I can't do what I did in the last problem where I use second calculate and I find a 0 because I don't have it going below and above the x-axis, so I can't find my left bound and my right bound and have it close the gap on the 0. Because I don't have a negative y value and then a positive y value, I can't do that. So I have to just get as close as I possibly can. And it does depend on how zoomed in you are, but like I said, even though this one is a little bit off from what I just now got, it still rounds up to 13. So it don't matter, okay? Use what you get in there. And if you can, check it by hand to see if you're on track. All right, for part B, it says at 11:30, the tank is full, valve is left open until 1:45 a.m. How many meters of liquid waste have emptied from the tank by 1:45 a.m.? Well, that's where you're just finding H of 0 and H of 2.25. Now, I did this by hand right here, obviously, in this work. But to find H of 0, you just do second calculate. You want a value, and you want it when it's 0. And there's the 4 meters that I got by hand. And then the other one is 2¼ hours. So 2.25, hit enter, and I get 2.735. That's exactly what I got here by hand. So that's what they're expecting you to do with the calculator. I do both. I do by hand and by calculator when I can, but the calculator is much quicker than writing down all this work. So the idea behind the graphing calculator problem or problems is that it's supposed to save you time because you're under a time crunch. You have to make sure that you're taking advantage of your time as much as possible. Okay. So it's supposed to be faster for you. All right. Okay, so then, and getting your points, because I know you can see the points breakdown here because this is my key for the review. My points breakdown would be based off of knowing that you're using your graphing calculator. So I wouldn't be expecting to see this work. I would just be expecting you to write the answer. Okay, so you don't think that you have to do both. You don't have to do it by hand. If you're not sure about what you got in the calculator and you're doing it by hand to verify, then yes, by all means, do that. All right, in letter C, this is where you're finding a derivative. So because we're finding a derivative, we need a new function. So that's just like the last problem. I need to hit math 8, ddx, and I need to populate in there the first function I already typed in, the y1. So alpha trace, hit the y1, x equals x. Okay, and that's all I got to do. But I don't want both of these to graph, because that might be a little confusing. So I want to unhighlight the equal sign on y1. That way only y2, the derivative, shows up on the graph, and I'm going to graph it. Take a drink of my kombucha while I wait. Okay. It doesn't matter what it really looks like. I need to calculate a value. So second, calculate. I need 1 for value. And we're supposed to find it at a time of 3 hours. So I got to plug in a 3 for x. And there it is, negative 0.473. And that's what I got, meters per hour, because those are the units that we're using. Okay, so that was letter C. And then letter D is the waste draining faster after 15 minutes or after 3 hours. Remember, your units have to be the same. So we're in terms of hours, we need to convert 15 minutes in terms of an hour. Well, 15 minutes out of 60 minutes is 0.25 of an hour. So this is what we need to find. We already have 3 hours, and we know that its rate is negative 0.473 meters per hour. Now we got to figure out, well, how fast is it draining in 15 minutes? Is that going to be slower or quicker? So we already know the answer, obviously, but let's just do it. So I'm going to type in 0.25. And there it is. I get negative 0.603, which is, or 604, sorry, which is faster, a faster rate. So the rainwater is draining faster at 15 minutes rather than 3 hours because of that statement right there. All right. So those are the calculator problems on the review. Everything else was non-calculator. So that would be it for that. Okay. So the next thing I want to go over is the practice FRQ. Now, in terms of when we went over this, I just went over this in class with you guys today. That was for this school year. In future years, I don't know when this fell, but you might have seen it already or you might not, depends. But I know as far as 2024, you guys have seen this already. We did it in class today. And we went over the calculator part, but we're going to do it again. You have the answer to this. You have a video of me going over all this, but now I'm going to focus on just the calculator. So same type of thing. We've got a tank. We have an equation that measures how fast the tank is going to be drained of coffee. Okay. And the first part is at what time will it be empty? It is empty when the function is equal to 0. So you have to set the function equal to 0. So, or in other words, you're looking for where it crosses the x-axis. You're finding the 0. Okay. So I need to go back to my y1 and y2 and clear them out, put a new function in. So I have to type in 2 times 1 minus parentheses x over 10, close parentheses, squared. And there is our function. Did I put the 2 out front? Yeah, I did. Okay, I didn't see it, so I freaked out for a second. All right, graph. And it does something similar as to the last FRQ that I just went over with you guys. So now I'm going to hit trace, and I'm looking for the smallest y value I can possibly get. It's getting small, 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 smaller. We've got an E, really, really small, and then it gets bigger again. So this is as small as it's going to get. So around here, either way, when you round it, it's going to, when you round this whole to a nearest whole number, it's a 10. So X is approximately 10, or T is approximately 10 hours. So that's how you get the 10, okay? Or you could do it by hand by setting the equation equal to 0 and solving for T and doing it by hand. Either way, it verifies that you should be getting a 10, okay? Always round to the nearest whole number to make your life simple. Keep these simple, all right? Letter B, at 11 p.m., tank is full, the valve is left open. How many meters of coffee have emptied from the tank by 1:30? So you have to figure out how much time has passed. Well, it's been 2.5 hours, so you need to know how much coffee was in there at 0 hours, or before they release it from the tank. And then you need to see, well, at 2.5 hours, now how much is in the tank, and then you have to subtract the 2 to figure out how much has been emptied from the tank. So H of 0, so I need to hit second calculate, and I'm trying to find a value, and I'm plugging in a 0. I get 2. So there were 2 meters of coffee in the tank at time 0. At 2.5 hours, there were 1.125. And then you subtract them, and that's how you get 0.875. So 0.875 is how much had been emptied. But I use my graphing calculator to find H of 0 and H of 2.5. Okay, you can plug it into the equation and do it by hand, but why do that when you could do your graphing calculator? And this is a calculator problem. It saves you some time. Okay, so you don't really need to show work like that. Your work would be in your response, because I'm assuming you're getting the answer from your calculator. And on the AP test, that's what they're assuming as well. All right, so there's that one. And then letter C, what's the value of H prime of 2? So now we're looking at the derivative of H. So we need to go back to our Y equals button. We need to, might as well unhighlight it while I'm there. And then for Y2, we need to hit math 8, ddx. I got an alpha trace, populate in Y1, and hit x equals x, okay? And we're going to graph that. Waiting for it to stop spinning, because it really doesn't matter what it looks like. I'm just trying to find the derivative at a time of 2 hours. So second calculate, 1 for value, x equals 2, and there it is, negative 0.32 miles per hour, which is what I got. And then, is the coffee draining faster after 30 minutes or after 2 hours? Well, we already know at 2 hours, this is how fast it's draining. So now we need to know 30 minutes. Well, 30 minutes is half an hour, so 0.5 of an hour. So now I need to figure out 0.5. And that's how I get negative 0.38. So it's draining faster in half an hour than it is at 2 hours, and then you have to do your write-up. Okay, so there was that. All right. And then the next thing I want to look at is the warm-ups. Okay. You're going to be seeing this, this year, 2024, you guys haven't gotten this yet. You're going to get this tomorrow. We're going to do this as our warm-up instead of a quizzes. So I'm only going to go over the ones where you needed a graphing calculator. Okay. So, because you're going to see me go over this in class tomorrow. And here we go. So on number 3, this is where we're really going to need a graphing calculator because you don't really need it in number 1 or number 2. So in number 3, it says if f of x is a function given by f of x equals 2e to the 4x power plus 3, at what value of x is the slope, aka the derivative, of the tangent line equal to 1? So I wrote here f prime of x equals 1. We're trying to figure out what x value lets the derivative equal 1. So I did all my work by hand, but technically with the calculator, all I have to do is type in the original function. So, oops, go to y equals, clear all this stuff out. I just have to type in 2 second ln to get the e, 4x power, arrow down, plus 3. There's my original function, okay? So, I don't need to see it on the graph, but there it is, okay? But now I gotta wait for it to stop moving and then, okay. Go back to the y equals button. Now I need the derivative. So that would be math 8 d dx. I'm gonna alpha trace so I could plug in y1 at x equals x, but I'm trying to find when the derivative is equal to 1. So just like the last problem, we need to subtract 1 from both sides so I can get a 0 on the right. So I'm going to have a minus 1 on the end of my function. That way, when I look at the graph, I'm looking for where it crosses the x-axis at, giving me a 0. So I'm going to scroll up and unhighlight the first equation because I only want to see the derivative on the graph. I'm just looking for where it crosses the x-axis at, and I'm graphing it. Luckily, my window, being the same as the last problem, doesn't affect anything. Just waiting for this to stop moving, and then I'll know that I can start finding the 0. There it is. Okay, so trace. And you want to try to get the smallest y value you can. I don't see my cursor. Hit trace again. Oh, there it goes. Okay, it was way up there. So negative 0.59, and then it turns to a positive. So I want to be at the last negative number. That's where I want to be at. So now hit second calculate. I want to find a 0, so I'm going to hit 2. My left bound is the last negative number that I get to the left of the 0, so I'm going to hit enter. Now I need my right bound, so I'm going to scroll to the right, and then now I'm at the very next number, which is a positive number, which was to the right of my 0. I'm going to hit enter, enter again. It's thinking. And so it's negative 5.198. So negative 0.52. And that's what we got by hand, or that's what I got by hand. Okay. So negative 0.52, that is it. Okay. So that's with the graphing calculator. Everything else is non-calculator on that. So that one was the only one where you needed a graphing calculator. All right, guys, so that's my video. I hope that helped. And yeah, good luck, you guys.